Hi, it's Justin, co-host of this podcast. We got some new shirts and stickers in, and we really want to give them away to fans of the show. All we ask is you share one of your favorite episodes on Twitter and DM the link to @CurryFence. And if you prefer email, drop a line to podcast@curryfence.io. Thanks, and I really hope you enjoy the show.
It's actually a very interesting point about core versus extensions, which brings us back to the question of reliability. The reason that the core is not kept very limited is to ensure stability, reliability, and security of the core. And so let's say if Google doesn't need all these extensions, then it can compile them out. It doesn't compile them in as core, and then we can guarantee quality. Now, everybody needs extensions, right? Because the Envoy is not just a proxy, it's a platform.
Hello and welcome to Committing to Cloud Native, the podcast where we talk about the confluence of open source and cloud native technology. We have a very exciting guest today from Google, but before I get around to introducing her, I want to make sure that the listeners know about the panelists, because our voices are going to come up and it's nice to know who we are. So I'm Richard Littauer. I'm your host today. With me is my co-panelist, Justin Dorfman. Justin, how are you?
I'm great, Richard. How are you?
Always good. And my other co-panelist, Zuri, how are you doing?
I'm great, Richard. How are you today?
Also still good. Hasn't changed in the last 10 seconds. Thanks for asking. All right. Getting to our guest today. Our guest is a distinguished engineer at Google, who, when I asked her to describe in more detail what that means, used a lot of words that I would like you all to hear. So I will ask her soon again. We have Anna Berenberg today, calling from San Francisco. Anna, how are you doing?
I'm great. How are you all?
I think we're all still good. Excellent.
Still good.
Thank you for asking. All right. So when I asked you how else I might introduce you, you said a lot of things about load balancing and so on. What is it that you do as a distinguished engineer? What is your specialty?
I'm Ubertl for load balancing products and technologies at Google. I work to make sure that load balancing works for both Google products as well as Google Cloud products. And I've been at Google for 15 years doing just that.
So I have a silly question. 15 years is awesome, by the way. Wow. I'm unfamiliar with the term Ubertl, and that may just be me, but in case it's any of our listeners, could you describe what Ubertl means?
Well, there are very useful people as engineers who implement code, and then you have TLs who actually guide them to build and design services and systems. And then when the scope becomes too big for one TL to cover, then you have multiple TLs. And then you have Ubertls who work with the TLs. It's like hierarchical system where Ubertls now guide and design and architect a whole areas and the families of products.
Technical lead. Got it.
Yes.
Technically, what you've been doing at Google Cloud, I mean, since 2015, you've had this job, is you drove the modernization of Google Cloud compute application networking by embracing emerging cloud native technologies using Envoy proxy with traffic directors, open service mesh, and universal control plane that powers all Google Cloud applications load balancing products. I just read that from your bio, which is why I was able to rattle it off so fast. Can you describe in more depth what that all meant?
So we had our own proprietary load balancing proxies and control planes. And then a time came when we realized that for Google Cloud to achieve its principle, Google Cloud considered itself to be open cloud, where we embrace open source technologies. And we basically, essentially, you can think about cloud without borders. Because once you use open source, then everywhere where the customer runs, they actually can become part of this open ecosystem of Google Cloud. And so with that, it became apparent that we need something different than just Google proprietary product. And at the same time, Lyft came out with this brand new proxy called Envoy Proxy, which had an amazing architecture. And I totally fell in love with that, to be honest, because it was such a beautifully designed proxy. And with that, I made a proposal and the proposal got approved that we actually Reblaze and build all our new products and Reblaze existing ones on Envoy as a proxy. And it's built quite wonderful experience. And why that philosophy? Because it allows actually to embrace data planes that run pure Envoy on somewhere else, whether it's on premises or on other cloud, and use our own control plane to manage them, as well as our managed LB products.
So ever since I've been using Google since like 98, it seems like it's never gone down. And is that true? Like, does Google search ever go down? I've never seen it down. It seems like it's very critical that it's always up.
Well, this is actually another passion of mine, is a design of 5 nines applications. And what 5 nines means, it's never down. It's the applications that basically always up 24/7. And how do you do that? What kind of architecture would you build? And with that, Google embraced what's called global applications. And that's why search is never down, because it could be down somewhere, but the traffic management and load balancing and routing and everything is done around places, zones, or regions, or basically everywhere where the stack potentially may be unhealthy, then it works around it and serves it from other healthy places. And the same thing inside of the application itself, the same technology is being used to make sure that you can always build around faulty hardware, faulty software, everything can fail. And then you still build an application to be able to survive it. Just out of interest, not for self-promotion, we published recently a paper titled Deployment Archetypes for Cloud Application that talks specifically about all sorts of deployment and global deployment as part of it.
Thank you, because that makes a lot of sense. And was your team responsible for building that out? Or because it seems like you know a lot about that type of part of the search engine.
No, not my team, but I work with teams that build infrastructure for the services. But the services become our customers. And what we want to do is actually solve customer problems. And how would you solve customer problems unless you understand what problems they're facing? And so we get to listen both to internal Google customers as well as external Google Cloud customers to understand what are their requirements. How do they want to build this 5 nines applications? What is the compliance requirements that also comes with it? Yeah, so it's all about listening.
I would say to me, Anna, you're SDN, and you're actually defining the software-defined network, which people may not be aware of, because those tremendous trends and revolutionary takes 99% in the backend side of the story, at the backbone, at the infrastructure of the cloud. But cloud flexibility, agility, scalability, and all the superlative and we can attach to a cloud is mainly available for the fact that data center used to be based on appliances and hardware became what we call cloud, which is mainly based on software stack that performing, doing all the routing and all the great work of networking and switching and whatnot, firewalling, et cetera, et cetera, et cetera. And the world is stepping towards this software-defined network. I believe, I don't know numbers or predictions, but they talk about ISPs one day also transforming to that type of infrastructure and 5G and so on and so forth. And here we are talking to you. Well, you're actually leading teams and doing design and defining eventually the software-defined network. So I wonder, sometimes you get to think of your part in this evolution of the significant role you've been playing in such a humble way all those years.
I don't think about my role in it that way. I think we live in a very interesting time, exactly, Zuri. Like you said, we at the cosm of SDN becoming requirement everywhere, because all the customers and all the users want to have policy-based workflows, I would say, right? So everything has to become policy-based. How do you propagate policy? How do you get this policy enforced? How do you do it in uniform way so that the consumers don't have to think, oh, I'm going to enforce one policy on a hop and another policy on another hop because it comes from different provide or different functionality. How do we bring networking together under one umbrella in a way that a customer can define a single policy, let's say access policy, who can touch this bucket or who can talk to this service or who can actually go to internet, how all these policies can be defined in a very simple way and enforced in all network paths, no matter how many network paths are there and what equipment or what products do they use. If we get there, I think this will change how people think about networking. In fact, they probably stop thinking about networking. They stop thinking about security, right? And that's the goal of it. People should be thinking about policies and not the infrastructure that allows them to propagate and allows them to enforce. So yeah, my goal is for people to stop thinking about networking.
So I have a very silly question because I'm just not the expert. And I know that Justin and Zuri work on this stuff all the time with CuriFence. I don't. I'm largely here on this podcast helping to guide guests along. But I do need to ask, and you seem to be the expert, so I wanted to ask you. When I think of a proxy, I think of what I use to stop people knowing that I'm using the Pirate Bay to download Star Trek episodes. That's obviously not the only use for proxies. How are proxies used on a day-to-day cloud basis at Google?
There are multiple reasons for using proxy. In some sense, you can think of it as a choke point. So anywhere where you want to choke access to something and enforce policy and make sure that there is a control over traffic, you put a proxy in there, right? That's one way. So think about it as like a gateway, the place where trust domains meet together. Let's say you have one team of people who trust within the trust domain, you have another team of people who trust, and then you want to connect these two together. To connect these two together, you need a thing in between that would allow basically somebody authoritatively say, okay, this traffic can come in, this traffic cannot come in, this traffic should be augmented, this traffic should be thrown away, whatever. The other part of the proxy is, especially of reverse proxies, are load balancing. And so behind proxy becomes a load balancer. So you're able to hide actual workloads and size of workloads and deployments of workloads from the people who consume the service. And then you can scale up and scale down. And basically all of that happens on the back end intelligently. And no matter how much traffic is incoming, proxy can distribute it in an optimal way to actually serve the consumer as well as not overload a workloads behind.
Awesome. That's actually really helpful for me because I was confused how proxies interface with load balancers. Now I see that they're basically the same thing. It's just another term. That's really great. I know that you defined one of the first gRPC proxyless mesh, right? If not the first. Proxyless seems to, if proxies are so useful, what does proxyless mean and how does that work?
Well, actually, me defining it is probably too much of taking a credit. What I've done, I looked at how Google internally used service-to-service communication, and we have a proprietary protocol Stubby that has historically been used at Google. And what we developed actually a service mesh before service meshes were cool. And what that service mesh, what it did, it had a control plane, it has a data plane, and then control plane actually manages data plane, which is part of the Stubby transport and framework that is linked into the client code and the server code. So it's a little different from regular service mesh. And the reason regular service meshes, as we know it today, needs two proxies on both sides. The protocol is mostly HTTP, and so you cannot change the protocol in a way to fit into the traffic management as part of the application. And so what happened here in our case, we have data service to service communication that used between all microservices and services within Google. And you can imagine there are hundreds of thousands of microservices and services, and it's proved itself very successful. So when I looked at cloud and how important gRPC is to cloud, because it allows for much better productivity and velocity of cloud developers when using protobufs, and how well it fits with the Kubernetes as modernization. While Kubernetes modernization of compute and control plane, the gRPC is a modernization of application networking. So looking at this together, it was pretty easy to make a next step and say, okay, we are going to take a service mesh that we developed inside of Google, which is proxyless service mesh, and we're going to put it on gRPC. How do we do that? We actually reuse the same APIs that we're using for Envoy. And so you have a single control plane, and you have a data plane that is compliant to this API similarly to Envoy proxy. And now you can mix and match. One, you can have a proxyless service and client communication where all the traffic management, security, etc. is on a site. So the developer doesn't have to worry about them. It's done for them. While actually, it doesn't also need a proxy. And what it helps with it helps with 2 points. One, it improves latency because going through the proxy adds latency. It's not that important for regular application. It is super important for latency critical application that measure every millisecond and less than millisecond, as well as important for a very large deployment. So if you think about Gmail or something like that, some big application or customers that big, if you put proxy in each hop and you have these hundreds of thousands of microservices, your daily job will be restarting proxies. So the proxyless solve the problem of lifecycle management of proxies also. And so the way we've done it, we actually allow them to coexist. So in a single service mesh, you can have both proxyless and proxy.
So it's not just like some big cron job. It's actually like more optimized.
This is mind blowing, JD. This is mind blowing. I'm telling you what's going on.
I know.
So because APIs are the same, so you're going to get a feature parity, not full feature parity, because obviously a proxy is by definition can have more functionality because it's out of the process. It can restart independently, and if it crashes, the process doesn't crash itself, etc. So we have to be lots more careful with the proxyless gRPC, but it indeed allows for coexistence of applications that require super high latency requirement, super low latency requirement, as well as cannot afford to have so many proxies in deployment.
So I know one of the things that actually scares me, sometimes literally keeps me up at night, is that we live in a world we know that hardware has less bugs than software. That's a fact. And there are reasons for it. Logic gates, etc. Software, as they put it out in Andreessen Horowitz at the time, software is eating the world. Now, software is everywhere. Security defined by software. Networking is defined by software. Even proxy and proxyless are software defined, transportation and routing and so on, and all those amazing tech stack you just described. How can we sleep at night knowing that software, which known to be, that every software has bugs, and those bugs can easily, be exploited, taken advantage by malicious entities to do all those, attacks and breaches and so on. How do we make software more secure, especially critical pieces of actually handling infrastructure? What are the guarantees, the gatekeepers you put in place in your work, in your teamwork, day to day, to ensure robustness and safety and security?
Yes, this is an excellent question. And that's where security and reliability come together. And one of the things that we've done, let's say at Google for Envoy, we funded the whole team that is responsible for security of Envoy and the focus on reliability. For us, it's very important that Envoy doesn't have exploits, that it would never be crashed, because we're using it as foundation for our products. That's one thing. Another thing is, in general, culture of the teams. And I think Google has a culture very much tilted towards reliability. People think about reliability when they design systems, when they code it up. There are a lot of tools to make sure that testing is properly done. There is a fuzzing tools, right? Fuzzing is required for all interfaces. There are all sorts of paranoia, that is healthy paranoia, that is being deployed and required when you build infrastructure. Yeah. And what to say that reliability is more important than any functionality we can add. In some cases, we can think that we innovated just because we wanted to make it more reliable. So the innovation is not necessarily comes as the features that customers see, but how reliable we make the systems for the customer.
Can we talk a little bit more about Envoy? I'm not sure how far can you go in terms of, things of which are proprietary within Google, because it's not a secret that Google has its own flavors, plurals. Used to be a flavor of Envoy. Now it's probably, I'm assuming, flavors of Envoy. When we started CuriFans, we looked at, okay, what platform do we want to hook on as the first iteration of the product, of the solution? And we picked Envoy, not being aware of the very fact products, Google Cloud products, and apparently AWS and Azure, they are all following Google as usual and rewriting their own cloud stack on top of Envoy. So Envoy, to some extent, if not yet, will soon become the operating system, sort of the operating platform of the cloud networking, application networking. Now, there is a barrier, though, in Envoy in terms of having it that in one end, build the architecture you mentioned of which providing API and extendability in the first place. So Envoy's own feature, as we had Snow, one of the maintainers of Envoy, explained to us that when they discuss a feature of Envoy, they first look, can we implement that feature as an extensibility using the Envoy core API? And very rarely they will change the core. In most of the cases, Envoy development is done as Envoy extensions. This is how Envoy is built and extend and expand. So these vary, I would say, extendability and multiple API and extension you need to take into account in order to get started, provide some sort of barrier to beginners to begin with. But on the other end, once it's like using Vim as an editor. If you go with, the first day or two of the hustle, then you don't give up, then you find yourself in heaven, in a peaceful mind, you get to the right place. So what are things that you're doing, I would say, within Google or probably also outside of Google, having involved in open source related products to make the entry point easier for newcomers, for developers who come from different platform, different technology to adopt new technologies?
It's actually a very interesting point about core versus extensions, which brings us back to the question of reliability. The reason that the core is not kept very limited is to ensure stability, reliability, and security of the core. And so let's say if Google doesn't need all these extensions, then it can compile them out. It doesn't compile them in as core, and then we can guarantee quality. Now, everybody needs extensions, right? Because the Envoy is not just a proxy, it's a platform, as you said, which all the functionality is built as extension. One of the things I think is going to simplify in the future onboarding and extensibility. There are two things. One is standardized interfaces for remote filters. There is one type of authorization remote filters like external auth-z that has predefined API. So for that, you wouldn't even need to touch Envoy proxy altogether. You can run your filter collocated if it's authorization filter. So you can build the services based on that. And the other one that is now in development from Google developers actually is called external processing. So that one also is gRPC call out from proxy, and it'll call out to collocated service, and the service can actually do a modification of requests if needed. So that would allow onboarding of people without ever touching a proxy itself. The only thing that does need to change is a configuration. So the configuration is given by control plane to proxy, and then the proxy will call out remote services. This is like totally mind-boggling. And the second option is WASM, proxy WASM. That will allow developers to actually compile their code all together independently. The ABI are going to be standardized also. So it's going to be a standard way of getting the data in and getting the data out. And that's it. So I think you rightfully so, you said that usability should be a concern because more and more people using Envoy to implement, again, SDN, right? It's all about value-added services on the top of this platform.
Speaking of extensions and platforms, when is Google going to adopt QueryFence? I mean, we have a thriving community and we can, we have room for one more organization to start using QueryFence.
I'm not a network security person.
Oh, come on, Anna.
Justin, you're going to scare away all our guests if every
No.
you're like...
This is my KPI. This is my KPI. I need to get it.
But
Okay,
actually,
Anna, go ahead.
the interesting conversation to have is how Envoy as a platform can allow coexistence of a functionality in some cases could be competing, in some cases complementary. How can we build the offering where the consumer can decide I want some functionality from this product from cloud provider native offering versus I want to add on? Like in this case, Google Cloud has a product which is in the same space as QueryFence, which is called Cloud Armor. So it's an interesting proposition to develop an ecosystem like that.
Justin, you were not aware, but you should be aware at this point that Anna is a great inspiration on us while we were in the very early days of QueryFence. I had a call with Anna Projecta, who probably will follow you up on this podcast, Anna, and Matt Klein, that when we discuss actually QueryFence strategies, architecture, Envoy, and so on and so forth. So the contribution from Google is given already, JD, on a day-to-day.
Not enough.
Yeah.
Not enough. I need more.
Yeah. But don't worry. Don't worry. We're going to get
No,
there one
and
day.
you know what? I don't know that. And it should be probably in our About Us because that's all I know. I joined 2 months after the release. So, and I was half joking. I mean, obviously we would love it, but no, I wasn't trying to put you on the spot or anything.
Justin, you're ridiculous. All right. Here is a follow-up. So you do amazing work at Google. You lead many technical leads. You work really hard to make sure that this work is happening. And a lot of what you're doing has been groundbreaking, which is awesome. A lot of the stuff is open source. gRPC is open source, which is really great. Anyone can get involved. Anyone can look at the code. I mean, part of the standards and the principles for gRPC available at grpc.io is free and open. Allow anyone to look at what's there. My question is, how you incentivize clients, communities, coders, developers, projects, products like QueryFence to get involved in the planning stage, in the stage where you're working. Because Google is doing all of this work at the top, strategizing, and it's easy to say it's open source at the bottom. It's easy to say, well, we've made it open source. Go ahead and use it if you want. But it's much harder to integrate feedback from the community at the stage where it's how we're building all of this stuff and strategizing our knowledge base. So what are you doing? What are your teams doing to make sure that the needs of CuriFence and other projects like our listeners may have are taken into account at like the very high level?
Well, we're always listening. I think listening is underappreciated activity. And it's important to listen and important to understand not a single requirement, but a collection of requirements. Because when you have requirements from multiple people, then you're not looking at solving a point problem. You're looking at solving a actually generic problem. And so we're always listening and being attentive to people who both contribute to open source as well to our customers. And interestingly enough, our customers are also contributors to open source. So this creates an ecosystem in which we provide value-added services on the top of open source, while our customers take advantage of our value-added proposition. They actually improve open source offerings as well, and they make them more acceptable to them, especially on the consumption side. Are they going to produce Kubernetes operators, then configure whatever we want, whatever they need, while we're providing GCP APIs? There are a lot of this collaboration, natural, organic collaboration happening between open source community that, let's say, are not our customers, then the community that are our customers, as well as customers who actually are not very much interested in open source, but they will use cloud native, right? So you have a spectrum of customers, and all you need is to listen to understand what they're missing.
I love that answer. Thank you. We are coming up on time. So one of the questions I have is, aren't we started
I want to keep going. She's fun.
Okay, well then, go ahead, dude. Edit. Do you have more questions?
No, Paul, keep that in. I want it to be real and show that we want to keep going with Anna. Unless
we do.
Unless you got something, Anna. I don't want you to we don't want to abuse this privilege.
You're all funny.
Thank you.
See, Mom, I'm funny.
So my final question was, where can people listen to you? And do you have any final thoughts? And if not, where can people find your final thoughts elsewhere? Your other thoughts on this sort of stuff? Do you have a Twitter account, blog?
I never think of myself as a person anybody has to listen to. In fact,
listening is an underestimated activity. That is from you. So
also, I think this was really interesting to listen to. You have such a depth of knowledge, and your ease of explanation really shows that. You're able to take these really complex stuff and just say, yeah, here's how we do it. It's pretty cool. And it's really great. So you're definitely someone worth listening to.
Yeah, so I have Twitter. I'm posting some of it. I have LinkedIn account, but no, I don't have a blog.
That's okay. What's your Twitter account?
It's the handler is Kniga, is Kniga, and it's from Russian. It's book in Russian.
Ah,
I love that. Yeah. Well, thank you so much for coming on this podcast. It was really great, and I really appreciate you sharing your knowledge. I was thinking about, that's kind of lame. Okay. I was thinking about the etymology of envoy, because envoy means messenger. And as we all know, the Roman god of messengers was also the Roman god of flowers. So we talk of flavors, we could also think of a bouquet of different envoy things. And so I was trying to show something around, this was just really great. And now I feel like I've walked through a garden of beautiful flowers. So thank you so much.
I love how, Richard, you go, everyone knows, I don't know, and now I do.
Sorry.
And I always learn something either with a linguist or a couple new words that you defined. It's very interesting. Not only do I learn about committing to cloud native, I also get to learn about words and big words with Richard.
Thank you again so much.
Thank you.
Thank you.